All right, guys, welcome to my channel. So in this lesson, we are going to learn how to describe and graph intervals. So I'm going to write describe and graph intervals of real numbers. All right, so now we're going to use the variable x to represent all real numbers. Okay, let's go to the first problem. First, we have to graph the interval x is greater than or equal to 2. And we also have to describe. So let's go ahead and describe first. So let's describe this. We say this means all real numbers greater than or equal to 2. Good. And then we are going to graph. So to graph, we'll draw a number line and locate the origin, have x to the right. So we have the number 2. So we'll locate 2, 1, 2, 3, 4, keep going, 1, 2, 3, 4, keep going. And then we're going to the positive 2. So this 1, 2, that's positive 2 right there. And since we have greater than or equal to 2, so we mean all numbers to the right of 2, including 2. So I'm going to use what you call a square bracket. This is square bracket, square bracket. Okay, so when you have greater or equal or less or equal, you will have to use square brackets. Okay, so these are square brackets. Yes. So now, since we have all numbers all to the right of 2, I would just draw an arrow going to positive infinity. All right, so that means we have the representation here. One other way to write this representation is to write uh, 2 right here, have this, and close. So we keep, because it keeps going on and on forever. Yes, to the right hand side. So just another way you can represent the interval. All right, so this is the graph, and these are the intervals. All right, let's go ahead and try another example. Let's try example 2. So here we have -3 and x, and that is 4. So how do we describe this relationship here, or this expression right here? So we're going to say all real numbers greater than or equal to -3 and less than or equal to 4. Good. Again, let me emphasize how we're reading this. Okay, so a lot of students usually get this confused, so they read all the way from left to the right. No, this is not how you do it. So the way you read this interval, I'll show you right now. Okay, so you read starting from the variable. Okay, but then start from the variable, start here, start, okay, and then go to the left second. Okay, go to the left, okay, and then you go to the right. Okay, all right, so start, then to the left, to the right. So x is greater than or equal to, because so look at the direction now. So when reading from right to left, it is different now. So it would no longer, the sign, the symbol here would no longer be read as less than or equal to. So you now have to read it as greater than or equal to. So that's how you read it, because you're reading it backwards, or you're reading that flipped. Cool. So it will be x is greater than or equal to -3. Then you read it to the right now, which you can now read as x is less than or equal to 4. So this is what we're doing here. So let's go ahead and graph this. So we graph, and this is x, and then you have the origin of 0. So we have 1, 2, 3, 4. That's enough. Okay, you don't have to show all. 1, 2, 3. So that's -3. So we have -3 right here, and we have +4 right there. So now we have 2 square brackets here to use. So the first will be the square bracket this way, and second would be second bracket that way. But then you have to connect them, connect the 2 points. So these are called endpoints. And in this case here, you would say this this interval is bounded. Okay, this is what you call bounded. It's an example of a bounded interval because the endpoints are included. You can see the endpoints, and there is no positive infinity or negative infinity in the expression. So, but here you can call this one an unbounded interval because you have to include positive infinity there. Cool. All right, let's go ahead and try more examples. So say, for example, we have another problem here that says, how about, how can you describe this interval? How do you describe that? Let's go ahead and look at this. So we're going to rewrite this so that we can see exactly what we have. We're going to have x in the middle, and we're going to have, because we have open intervals, they're not square brackets, or okay, so we have open brackets. So then we can have negative infinity here, and then we have positive 7 over it. So again, we start and read this way and read that way. Okay, so like you would say x is greater than negative infinity and less than 7, right? But then when reading these, because negative infinity is not a real number, it is not a real number because we cannot get to that. We don't even know what that is. So we cannot get to that. So you can simply just write x is less than 7. Okay? So x is less than 7 is enough to describe this relationship here. So which means this interval here means x is less than 7. So then because of that, you say all real numbers less than 7. Again, to graph this, you have the graph this way. You know that your negative infinity is this way, right? Even though it's not real, but you know that because we use negative infinity, comma, positive infinity, open on both ends to represent real numbers. Okay, all real numbers. That's how we do to represent all real numbers. So we usually use just this expression right here. Again, you have the center, which is the origin, 1, 2, 3, 4, 5, 6, 7. So that's a positive 7. So in order to draw the representation, so you just have an open interval here, okay? Okay, open brackets, and just draw your arrow all the way facing to the left, and that's it. All right, let's try another example. Example 4. For example 4, they have this in words. X is negative. X is negative. All right, so how do we describe this? Again, we can describe this as an interval, all right? So let's go ahead and let me show you. When you say X is negative, so say you draw and graph this, you have X here, you have 0 here. All the negative numbers and numbers to the left of 0. Yes, left of the origin. So all the negative numbers are this way. They're this way, right? All the negative numbers, they just after 0 to the left, all right? So you have all the negative numbers this way, and which means you have negative infinity this way. So in order to write this, it just means the interval can be represented as that, okay? So now again, what this means is x is less than 0. X is less than 0. All the numbers this way, they're all less than 0. So to write this, you just say x is what? Less than 0. So all real numbers less than 0. So this is how you can describe that in words. All real numbers less than 0. So this is how you can do this. And then you can see the graph over there. So the graph is just simply x here, and you have 0 here. You start all the way from 0 away from 0 and just go this way, and then just have your open interval that way, okay? Something like that. All right, this is how you can graph x is negative. So let's go ahead and look at some more. Okay, so you have another example, say example 5, where it says x is greater than or equal to 3 and less than or equal to, say, 8. This is what we have. So we go ahead and write this interval here. I'm gonna let you just pause the video and try to see if you can write this. Welcome back. Now, to write the interval for this, we say we have x is greater than or equal to 3. So remember that we start from the variable and then we write your greater than to this direction, because you got to go to the left, right? Remember, you got to go to the left. Start from x, go to the left. Greater than or equal to what? 3. Yes. So 3 there. And less than or equal to 8. Less than or equal to 8. So this will be to the right. So now this is how it looks like. So which means I can use square brackets like that to represent this information. So you have less than or equal to, less than or equal to. So let's go. Greater than or equal to. All right, let's go. So now how do you graph this information? So I just draw my number line, locate the origin, and have x to the right. Have 1, 2, 3, 4, 5, 6, 7, 8. And then I have 1, 2, 3. That's what you have here. Number 3. I have 8 right here. Right, so we have square brackets. So I'll cut to the right and cut to the left and connect. So this is how it looks like. So this is again bounded because you have endpoints. So the endpoints 3 and 8. So this is good. All right, I think we'll do one more example. Example 6. Let's go ahead and look at this expression. All right, so this would mean x in the middle, and to the right of that you have -4 or equal to -4, and then I have my open bracket 2. All right, so this is what we have here. So this is again not very easy. Yeah, sometimes it can be confusing. Like, hey, I know my students always ask me why you have less than symbols twice in the expression, and then you're still reading something and say that represent greater than. So so remember that if you have this expression this way, this expression here, okay, this inequality here, you cannot read from the number. You would not, it is not appropriate to read as, I mean, it is good. It makes sense to read from the left, but then when you're trying to have intervals, you have to be very careful. The way to read it to make sense is not done from the number to the variable. So you have to read it backwards like this. So this expression simply means x is greater than or equal to -4. So these two expressions are equivalent. So this is how you read. So always try to read from the variable to the number. Okay? So that's why this is the representation we have here. So it will be x is greater than or equal to -4 and less than 2. So we have all real numbers because we know x represents all real numbers. So we always start with all. All real numbers greater than or equal to -4 and less than 2. So this is how you would do that. And then we're going to go ahead and graph. So to graph this interval, we have to locate the origin, and we have -4. So 1, 2, 3, 4 to the left, and we have 1 and 2. So this is going to be your number 2 right here. And that is going to be your -4 right there. So again, to graph this, I would have to use square brackets for -4 and open that to the right, and then to the left, I would have to use what? Open bracket. So now I'm going to have to shade and connect them, connect the endpoints. If you have them. Okay, so this is how you do it. Again, this is bounded. Yes, this is bounded interval. Okay. All right, so this is all about how you can do this. All right, let's go ahead and talk about how can you uh, use inequality to describe an interval. Suppose you're given a graph or you're given an interval and they say use inequalities. So I've been using them here. So, but then I just to emphasize that, I give you more examples. Let's go to another example, say number 8. For number 8, we're going to have to use inequality to describe the intervals. So the first one here is looking like I have this expression of this interval. All right, so let's go. So use inequality. All I got to do now is this one is open. Okay, it's an open, uh, and this is what? Square brackets. Okay, square brackets. Okay, so now this is what I'm going to do. So I'm going to have the variable in the middle, so it will be x. Yes. Then to the left of that, I will just do greater than or equal to -2, and since I have open, it will be strictly less than 2. So this is how you do it. Number 9, example 9. So I'm going to have another one. Say you have a graph. Okay, you're given a graph, and then you have 0, 1, 2, 3, 4, and you have open, and then you have the arrow going all the way, to the left. It doesn't matter if you have 1, 2, 3, 4, 5, 6, whatever. Okay, so you have number 4 right here. So how do you write this as an inequality? Again, here it means that what? All the numbers that are less than 4, because it's going to the left of 4. So this is x is less than 4. X is less than 4. All real numbers less than 4. All right, I think this is good enough. Let's do another one. Number 10. You have negative infinity, you have 5, and you have square bracket. So for this here, see that this means this is 0, 1, 2, 3, 4, 5, and negative infinity is to the left. Okay, so you have numbers that keep going forever. So what you have here is you have the number here moving from 5 and going all the way to what? Negative infinity. And then we know negative infinity is not a real number. Okay, so because of that, we just have x is going to be less than or equal to 5. X is less than or equal to 5. Let's take one more example. Say, for example, you have this expression, that's the number 11. You have a graph this way, and you have the square bracket on -1, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just say that. Yeah, you have 0 here, okay? And then you have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I have 7 here, okay? And you have a square, and you have an open bracket, not a square bracket. So how do you write this as an inequality? It will just be x is greater than or equal to -1, but less than 7. So again, this is bounded, and you can see that it's bounded because this can be connected. So the endpoints are connected here. So this is how you do it. And then they can actually ask you to tell if some intervals are bounded or not. Sometimes they can ask you to tell if they're bounded. So let me just say bounded or not. Are they bounded or not? Let's take number 1. For example, -3, 5 square closed. This is bounded because the endpoints not contain positive infinity or negative infinity. So you don't have that. So that means it's the bounded interval. Let's take another one. -10, -6. Yes, this is also bounded because I do not see positive infinity or negative infinity in the interval. Number 3. How about you have that, and that? This is considered unbounded because you have negative infinity, okay? 4. What about if you have 5 and positive infinity right here? Again, this is going to be unbounded. Okay, so this is all we have for you in this section. So I hope you have been able to learn something. So I'll see you in the next session. Thank you very much.